All right, geometry, lesson 68, page 451. We're going to be talking about introduction to trigonometric ratios. I can say trigonometric normally, but then whenever I see how it's spelled, suddenly I have trouble saying the word. But trigonometry is the study of the relationship between sides and angles of triangles, and there are three basic ratios in trigonometry that can be used to find measures in right triangles. Now you'll notice that in your book, it's written all exactly the same way, except I capitalize the word right. So you understand that we're working with right triangles when we work with these. Okay? And trigonometry is a huge section within mathematics. We cover trigonometry in algebra. We cover trigonometry in geometry. We cover trigonometry in pre-calculus, right? We do a lot with trigonometry, and it's based around triangles. And what's interesting about triangles and why it's such a big deal, it's not like we have quadrometry, right? I mean, we do a lot with squares, but if you notice, even in Erica's question, what was it, number 2? What did we end up doing with that square? What did I cut it into? I cut it into a triangle. Well, not too many lessons back, we covered how to find the area of an octagon, right? And what did we end up doing to find the area of that octagon? We made a triangle, right? So that's why trigonometry becomes really, really important. In Algebra 2 right now, we just had a lesson yesterday about unit circle, and we ended up splitting things into, you guessed it, right triangles. So trigonometry, the reason it shows, we make such a big deal about it, is because it shows up everywhere. Triangles are vastly important because we use them everywhere. In all other polygons, we can find things out about them by splitting them into smaller and smaller triangles. If you remember some lessons back, we talked about how to find the interior angle measure of a regular polygon. What did we do? We split it into triangles, right? We took the number of sides, we subtracted 2, and we multiplied it by 180, because if we take all those points back to a single point, we wind up with a whole bunch of triangles. Okay? But we're going to use some 3 basic trigonometry ratios. And the 3 ratios are called sine, cosine, and tangent. Okay, the 3 ratios are the sine of an angle, the cosine of an angle, and the tangent of an angle. And I'm going to try to go slowly enough through here that I keep everybody on board, because if I lose you, then you're going to have a really hard time, not just today, but from here on out. Okay? Because there are things that you need to start to memorize today so that you understand it, can continue to use it tomorrow and from here on forth. Okay? This may be, for some of you, the last math class you'll take, but in high school, okay? Those of you that move on, you're going to come back to the same stuff. Okay, so learn it today so that you understand it tomorrow. Trigonometric ratios is a ratio of 2 sides of a right triangle. What we should understand when we talk about ratios is that what we're really talking about is a fraction, right? Something over something else, right? So we understand what a ratio is. All right, so let's talk about these ratios. Let's talk about the first one, which is sine. Now, if you've got a graphing calculator, you'll want to use it today. Okay, we'll see it. You'll pull it up. All right, I'll pull up a graphing calculator real quick here so that you can see this. You'll notice that there are 3 buttons on this graphing calculator. Now, granted, they're not spelled all the way out like what we saw, but you'll see sine, which is going to look like sin, cosine, which is COS, and tangent. Okay? And above that, you have inverse properties of those 3. You won't need those today. Okay? But we have sine, cosine, and tangent. How many of you are familiar with sine, cosine, and tangent to some degree? This isn't your first time running into this. Okay, good. They're about half of you. Okay? Good. So you guys got kind of a leg up. Sine is a ratio of opposite over hypotenuse. And we've defined it down here. In a right triangle, the sine of an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. So the first thing I'm going to do is identify the right angle. And the reason I'm going to identify the right angle first is because the hypotenuse is always the hypotenuse. No matter what angle I'm using, the hypotenuse is always the hypotenuse. Okay? Can somebody come up here and put an H where the hypotenuse should go? Okay, thank you, Brady. Exactly. It is the side opposite the right angle. Because I don't know what any of the side lengths are, so can I use the definition that it is the longest side of a right triangle? No, I can't here, right? Because I don't know what any of the side lengths are. Okay? Nobody will hear on the recording that you got that wrong. Well, they wouldn't have known who I was talking about until you spoke up, Brady Reynolds, for posterity. Okay, so everything else is based upon what angle I choose, because I have two angles that I can go from, right? I can either pick this angle to find the sine of, or I could use this angle down here, because everything else is determined upon what angle I'm going from. Now, let's say that we're going from the blue angle, okay? Can I get somebody else to come up and put an O on the side that is opposite the blue angle? Anybody? Caleb? Just put an O on the side that's opposite the blue angle. Perfect. Okay? And can I get somebody else to put an A on the side that is adjacent to the blue angle? At this point, it should be pretty easy, because there's only three things that we're going to work with, which is opposite, adjacent, and hypotenuse. Do I already know which one is hypotenuse? Do I know which one is opposite? So what one must be adjacent? Whatever's left, right? Okay? So if I know what numbers are there, then I can set up a ratio. Now, you might have trouble remembering what is sine. Well, sine is a ratio of opposite, the length of the side opposite, over the length of the hypotenuse. So we come up with an acronym. SOH, S-O-H. Sine equals opposite over hypotenuse. You need to know this, because I'm going to ask you, what is sine? Anytime I ask you what is sine, you're going to tell me opposite over hypotenuse. Okay? Anytime I ask you what is hypotenuse, you're going to tell me the side opposite the right angle. All right? So do we know how to respond to those two questions? Okay? What is sine, class? Okay? What is hypotenuse? Side opposite the right angle. Okay? And if I ask you what is opposite, it's obviously the side that is opposite that angle. Okay? Now, I may not ask you that question. Okay? So we have sine first. Then we have cosine. Okay? Now, I'm going to put my right angle up here. Okay? It goes right there. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Okay? So where should my H go? What is opposite the 90 degrees? So it should go here, correct? All right. Now, can opposite change based upon where the angle is? Can adjacent change based upon where the angle is? Sure. Okay? If my angle is still here, okay? Darian, can you tell me where adjacent is going to be? On the left? Okay? Which means opposite is here, right? So I'm going to go with this side over that. Okay? And if I know what those numbers are, I'm going to set that ratio up that way. So if I have, let's say we have a 3, 4, 5 right triangle, my cosine equals 3 over 5. You with me? Okay. Adjacent over hypotenuse. Now, if I pick a different angle, let's say I pick this angle down here, well now this is adjacent and this is opposite. Okay? So if this is still 3 and 4, then my ratio changes to 4/5. Okay? All right. And my mnemonic there is ca. Cosine equals adjacent over hypotenuse. So if I ask you what is cosine, you're going to say adjacent over hypotenuse. Okay, now you already know what hypotenuse is. What is cosine? Class? Okay. A lot of people struggle with adjacent more than anything else. And what I want you to understand is there are only 3 designations for a side. Hypotenuse is always the side opposite the right angle, which means the other 2 sides you got a 50-50 chance at guessing. Should we be able by now to determine which side is opposite of an angle? Yes? So even if you struggled with adjacent, if you labeled hypotenuse and then you labeled opposite, what's left? Adjacent. So if you struggle with adjacent, just label hypotenuse and then label opposite, and you'll always get adjacent right if you understand those things. All right? And the last one is tangent. Tangent is opposite over adjacent. So whenever I ask you what is tangent, you're going to tell me opposite over adjacent. So this may be one of the tougher ones just because we got our hypotenuse here. If this is my angle, this is opposite, this is adjacent. If we were dealing with a 3, 4, 5 right triangle, this is going to be 3 over 4. Okay? So my recommendation to you is label the sides. Okay? Even if you're just putting O, A, and H, so that you understand right off the beginning on every triangle what is opposite, what is adjacent, what is hypotenuse. If you struggle with it. If you're good with it and you can get it right every time, you don't have to label anything, but I think that it'll help you. Okay? In a right triangle, the tangent of an angle is the ratio of the length of the leg opposite the angle to the length of the leg adjacent to the angle. We will never base anything off the right angle. All right? It's never going to be, well, what about if this is my angle? Then the hypotenuse would be the opposite. We'll never do that. It'll always be based upon one of the 2 acute angles. Always. Okay? We will never, ever, ever work with that angle. Okay? Because that angle is always 90 degrees. Okay? Because it is the right angle. All right. Are there any questions up to this point? No? All right. I believe we're at the end of that. So let's get into our lesson. Okay, where are we at here? We're at lesson 68. Oh, no. No, we're not out. Here we are. All right. There for a while, I thought I was in algebra 2. Okay, so we want to find the sine, the cosine, and the tangent of angle B. So the first thing I want to do is determine where angle B is. Okay? What number or what side represents opposite? 33. So I'm going to put an O. Okay? What is adjacent? 56. What is hypotenuse? 65. Okay? So let's do sine first. Sine equals what, class? Opposite over hypotenuse. All right, minor. What is opposite to angle B? I just want the number. Aaron, what is my hypotenuse? All right, so I have 33 over 65 for my sine. So far, easy? Okay, cosine. Okay, Okay, Austin, say that again for me. What is adjacent? 56. Okay, what is hypotenuse? 65. Okay, and finally tangent. Opposite over adjacent. Thank you, Darian. Darian, what is opposite? And what is adjacent? 56. All right, I'm less concerned with what the multiple choice answer is than I am that you know how to find the right answer, and I think the right answer is B, if I've got that right. Okay, sine, cosine, and tangent. All right, so far we feel pretty good about it? Yes? Heads wobbling up and down? Okay. All right, now we're going to switch gears here a little bit, and let's talk about using our calculators. Everybody have a calculator sitting next to somebody who has a calculator that they can look at. Okay? Do you guys need to borrow one? Or do you have one? Okay. All right. So, we're going to pull up our calculators here. This is why I require that you have one. Okay, I'm going to clear some things out here from the other class. The first thing I want to do with this is I want to make sure that my calculator is in degree mode. How do I check that? Well, we go to mode. We come down here. Is my calculator in degree or radian mode? So I need to change it, right? All right, but before I do that, I want to show you what it's going to look like if I don't. Okay? I want to show you that it's going to give me the wrong answer. Okay? The question is, what is sine 23? So I'm going to hit the sine button, and I'm going to hit 23. Okay? And I'm going to hit enter. It gives me negative 0.846220. And if you'll notice that that is the answer for C. So if I did the wrong thing, if I had my calculator in the wrong mode, would I find an answer? Yeah, I'd find an answer. Would I find the right answer? No. Okay, so that's why you're going to see it's important to have it in the right mode before we start. I'm going to go down here. Now, if you ever reset your calculator, and which I do fairly often because they just have a tendency to get kind of quirky, every time you reset your calculator, you need to go in and make sure that your calculator is in degree mode because it will automatically reset it to radian mode. Okay? So I'm going to come back in here. I'm going to hit sine 23 again. And we'll see how different the answer is. Okay? Notice this time it's 0.39, which is the answer D. Okay? So the difference between having the right answer and the wrong answer is making sure that your calculator is set up correctly. Okay? Now, go ahead and plug in cosine 49 and tell me what you get. Okay, and since we're rounding to the nearest hundredth, we should get 0.66, right? Okay? I want you plugging this in your calculator so that you're seeing how these numbers come out, right? You are familiarizing yourself with it. Okay? Everybody able to do that? Okay? What is tangent 58? Irregardless if you know it's going to come out to 1.6, make sure that it is 1.6. So you plugged it in, you got it right. You say, what's the purpose to this? It's muscle memory. Okay? A lot of it's just muscle memory. All right, 3. Vinay is building a ramp for loading furniture onto a dock. The trailer's 2.8 feet off the ground. To avoid making it too difficult to roll furniture up the ramp, he decides to make the angle between the ramp and the ground 15 degrees. We want to find the length of the ramp to the nearest hundredth of a foot. Now we're getting into a real world situation. I know that we're running out of time here. And I'll probably make this lesson in 2 parts. So I'll finish this lesson with the other class, and I'll post both parts on your class page so that you can go back and watch and see how the rest of these questions were answered. But we can do this question. Actually, we've got more. I always assume that we get out of here at 36. It's like 48, isn't it? Okay. All right, so we probably have a little bit more time. Okay, so the first thing we're going to do is identify the angle that we're working with. What angle am I working with? A, B, or C? What do we think? A. Because that's the angle that I have a measurement for, right? Yes? Okay. So we've got this. Now let's go ahead and label all our sides, opposite, adjacent, and hypotenuse. What is 2.8? Opposite. What is AC? Adjacent. And what is my R? Hypotenuse. Okay. And we know that sine is opposite over hypotenuse. We know that cosine is adjacent over hypotenuse. We know that tangent is opposite over adjacent. So now what we're looking for is which trigonomic function is going to use what I need it to use. Okay? We know that we have 15 degrees is going to be equal to a ratio, right? And I know that I'm going to use opposite, adjacent, or hypotenuse. I know that I have to use one of them, right? I'm trying to solve for r. What is r? Hypotenuse. Now, in both trigonomic functions that use hypotenuse, where is it located? At the top of the ratio or the bottom of the ratio? Bottom, because it's opposite over hypotenuse and adjacent over hypotenuse, right? So I know that I'm going to wind up with r on the bottom, right? Okay? Now, can I use adjacent? Why not? Do I know anything about it? I don't have any information. Okay? Can I use opposite? Yeah, because I have information. So what am I going to put above r? 2.8. So what is 2.8 over r? O over h. What trigonomic function uses O over h? Sine. So I'm going to put that trig function here. Sine 15 degrees equals the ratio 2.8 over r. You with me so far? How many did I lose anybody in here? No? Nobody was going to admit it. But we need to solve for r. Okay, so this is our process. We're going to multiply by r on both sides. That's going to give me r sine 15, because what I'm doing here is I need to isolate the variable r. Now this is r times sine 15. Sine 15 is all one thing. Okay? What do I need to do with sine 15 to solve for r? Divide by it. Okay? On both sides. This is probably the most difficult type of question that you will do in today's homework. R equals 2.8 over sine 15. So let's look at how to do that. One, do I need to make sure my calculator's in degree mode? Yes. Okay. Now, if you already checked it, you're probably fine. What I'm going to do here is I'm going to do 2.8 divided by sine 15. That's going to tell me the value of r to the nearest hundredth. So I want 10.82. 10.82 feet. Okay? Now the other thing that we should understand is that it's the hypotenuse, so it has to be longer than 2.8, right? So I should have known right off the bat, we knew it wasn't going to be C, right? The rest of them, maybe. Okay? But do we understand how to do this question now? Okay? Hopefully. Let's clear this guy out. Number 4. Some of these are a little easier, a little less time consuming. Use the tangent function to find A. Okay? So let's start off with tan. What should go next to tan? What went next to sine in the last question? The degree. So what should go next to tan in this question? 67. Okay, what does tan equal, class? Opposite over adjacent. What is opposite to 67? A. Okay, what is adjacent to 67? What's that? 7. All right, this is like the last question, but easier. Okay, because all I have to do to isolate A is multiply both sides by 7. So 7 tan 67 equals A. So there's no second step where I have to divide by tan 67. All I have to do is plug in 7 tan 67, and A is 16.49. All right, are you guys doing that with your calculator? So it's not just watching me do it, it's muscle memory, it's me. You will remember it more when you do it yourself. Okay. All right, the rest of these, fairly simple. Okay? It's plug it in. All right, use the calculator to evaluate the expression cosine 37, round your answer to the nearest hundredth. I'll give you time to work that out. Erin's going to tell me what she gets when she has it. To the nearest hundredth? What's after that 9? Which is going to do what to that 9? Round it up to a 10, which is going to round the 7 to a, and then, so what I have is 0. But I still want 0.80 because I still want it to the 100th. Right? So be careful with those. Okay, 0.80. Okay, let's see. Mick, can you tell me what you get when you evaluate the expression sine 73? 0.96. Very good. Okay. Let's see, somebody else. I don't call on Miss Ayala a whole lot. Miss Ayala, tell me what tan 43 comes out to. 0.93. 0.93. Okay, is everybody getting these numbers as you plug them in? Okay, great. All right, we've only got 2 questions left. I think we're going to be able to make it 8. Give the sine, cosine, and tangent of angle E. Okay, so we want this. So we know that at least 2 of these trigonomic functions are going to use what? No? Hypotenuse. And do I know the hypotenuse of this right triangle? So the first thing I need to do is solve it. How do I solve it? Pythagorean theorem. Good. 8 squared, I heard Brady say, plus 6 squared equals c squared. All right, what is 8 squared? 64. What is 6 squared? 36. What is 64 plus 36? 100. What do I do with 100? Square root it. What's the square root of 100? 10 equals c. So this is a Pythagorean triple. I can erase this information now. All right. Sine. Class, what is sine? Opposite over hypotenuse. What is opposite to angle E? 8. What is hypotenuse? 10. Can I reduce this? What is it? 4/5. Okay, 4/5. We always want to reduce our ratios. Cosine. What is cosine, class? Adjacent over hypotenuse. Erin, what is adjacent to angle E? What? So it is both. What is hypotenuse, class? No? Well, yes, it is. But what is the definition of hypotenuse? Not the longest. It is the longest side, but it's the side opposite the right angle. 6. There we go. All right. So opposite is always. So this is where we want to go back. Opposite, adjacent, hypotenuse. If I do that at the beginning, then I'm never going to get lost, right? So we've got 6 over 10, which is 3/5, right? Okay. Tangent. What is tangent, class? Matt, what do I get? What's that? 8 over 6? 8 over 6, does that reduce? Divide both numbers by 2, I get 4/3. All right, so I've got 4/5, 3/5, then 4/3. Okay, we've got one last question to work out. You can see why now I make a big deal about understanding opposite, adjacent, and hypotenuse, because if we don't understand those things, we're going to struggle all the way through. Okay, if tangent equals 4/3, what is cosine theta? Okay, so this one's a challenging question. Notice that they don't draw a picture of a right triangle for me. So we're going to do that. Okay? Now, what is tangent, class? Opposite over adjacent. So I'm going to pick an angle. I'm going to call that my angle. All right? And so this is what? Opposite. This is, and this is, okay? Based upon, it says tangent is 4/3. Where do I put the 4? Opposite, so it should go there. Where do I put the 3? Does anybody know what my h is? 5? 4 squared is 16, 3 squared is 9, 16 and 9 is 25. What's the square root of 25? 5. We should also recognize that it's a 3, 4, 5 right triangle. So cosine, what is cosine, class? Adjacent over hypotenuse. What is adjacent to my angle? 3. What is hypotenuse? 5. So my answer is 3/5. Okay, do we have a basic understanding? Enough to get started? Okay, ask questions if you need to. We're going to stop right there. You guys have like 3 minutes, so get cracking.